What is this?
This is rusting.
What is rusting?
Alright, so today we will discuss on the topic of redox reaction, but more specifically on rusting of iron. We chose this topic because rusting of iron occurs in our daily life, and it might be beneficial for us if we have the knowledge about the process and how to prevent it from happening.
Rusting is said as the corrosion of metal, but specifically for iron metal. The process of rusting will occur with any material such as iron, like iron nails, iron rod, and iron utensils, exposed to the water and oxygen or moisture in the air.
Let's get into the process of rusting iron. When there are water droplets on iron nail, the iron nail acts as anode. This means that iron nail help in release electrons and oxide to form iron to ion. The electrons that are released by the iron nail flow to the edge of the water droplet through the iron surface. This is because the edge of the water droplet now acts as a cathode. Therefore, the electrons from the iron nails are received by dissolved oxygen and water. At the edge of the water droplet, this causes the oxygen and water to reduce and form hydroxide ion.
At the surface of the iron nails, iron to ion and hydroxide ion combine to form a green solid called iron to hydroxide. Iron to hydroxide then oxidized to a brown solid called hydrated iron to oxide, which is also recognized as the rust by the oxygen in the air.
Now that we have talked about the stages in the formation of iron, we will discuss further and take a look on how other metals can affect the rusting of iron. Situation 1. Iron nail is coated with zinc metal. When the iron nail is covered with zinc, the iron nail will become more resistant toward the rusting. This is because the zinc metal is more electropositive than iron metal. Therefore, even when the protective layer, which is zinc, is exposed, the iron nail is still protected from rusting. The zinc metal acts as the anode and release electrons. The zinc metal is oxidized to form zinc. The electrons that are released from the zinc metal move to the water droplets edges because it acts as the cathode. Then, the electrons are received by oxygen and water and is reduced to form hydroxide ion. Zinc ions and hydroxide ions on the zinc metal surface combines to form zinc hydroxide. Therefore, the zinc metal is corroded and iron metal is protected from rusting.
So that's what happens when iron nail is covered with more electropositive metals such as zinc and magnesium. Now, let's take a look on what happens if iron nail is covered with less electropositive metals such as silver. Alright, so when the iron nail is covered with silver, the iron nail will not become more resistant towards the rusting. This is because the silver metal is less electropositive than iron metal. Therefore, even when the protective layer, which is silver, is exposed, the iron nail will not be protected from rusting. The iron metal acts as the anode and releases electrons. The iron metal is then oxidized to form iron to ion, and the electrons that are released from the iron metal moves to the water droplet edges because it acts as the cathode. Alright, then the electrons are reduced by oxygen and water and is reduced to form hydroxide ion. After that, the process of rusting will continue until the formation of hydrated iron to oxide, which is known as the rust. Therefore, the presence of silver metal that covered the iron nail will not prevent the iron nail from rusting. Instead, it will accelerate the formation of rust on iron nail. This is because the iron nail is forced to oxidize at a faster rate when in contact to a less reactive metal.
First, coating an iron metal with protective layer. Use a layer of coating such as with tin metal on food cans, applying paint on iron gate, oil on bicycle chains and grease on bolt, nuts and screw. Wrapping an iron surface with plastic such as on clothes hanger. applying a coat of chromium metal on iron material such as water pipes.
The next one is electrochemical protecting, covering the surface of iron with a more electropositive metal, such as zinc or magnesium, provide a sacrificial protection. Alternatively, a red primer can be applied to be metal surface as a protective barrier. Large iron structure like bridge, underground pipes, and metal sheet are highly suited for protection using sacrificial metal such as zinc and magnesium. Lastly, laying is another effective method to prevent rusting. Throughout this process, iron metal is melted and added with chromium to produce stainless steel, allowing form a hard layer of oxide that adheres strongly to the surface of the iron, thus protecting the iron from rusting. This specific method is highly suitable for medical and surgical instruments.
Next, the example of electrochemistry in industry. First, electroplating. A thin layer of metals such as chromium, nickel, silver or gold is deposited into another metal to improve its appearance, prevent corrosion or increase wear resistance. For example, chrome plate car parts, gold plate jewelry. Second, electrolysis for metal extraction. Electrolysis is used to extract reactive metals from their molten compounds. For example, extraction of aluminium from aluminium oxide. Third, electrorefining. Electrolysis is used to purify metals to a very high purity. For example, purification of copper for electrical wiring.
During electroplating process of iron forge, there has 6 conditions that must be followed. First, metal to be plated, which is forged, needs to be cleaned first with sandpaper and distilled water. Then, low electric current should be used, dilute electrolyte solution should be used, and duration of the electroplating must be long. Other than that, metal to be plated must be rotated slowly and consistently throughout the process. Metal to be plated must be fully immersed in the electrolyte. During the process, zinc is made as the anode and the iron material such as forge is made as the cathode. The electrolyte used is zinc sulfate solution. The zinc electrode and iron forge are completely immersed in the solution, and the iron forge is consistently rotated throughout the process. This process is then continued for 1 hour.
At the anode, sulfate ion and hydroxide ion are attracted. Therefore, the zinc electrode donates 2 electrons to form zinc ion. The electron released at the anode move to the cathode through the external circuit. At the cathode, hydrogen and zinc ion are attracted. Zinc ion receive 2 electrons to form zinc metal. The zinc metal that are deposited thoroughly on the iron forged surface is said to be the protective layer.